Okay, we've got to be really careful. So far in all the lessons on sections 5.1 and 5.2, the function was above the x-axis. The graph of the function was above the x-axis on the interval a to b. In other words, our function was positive on the interval a to b. In the examples I chose and in my discussion and explanation. But what if this is not the case? Now, if the graph is above the x-axis on AB, the definite integral gives us what? Gives us area between the graph of f and the x-axis. And we know that area is always positive. I mean, an area question is how much carpet does it, how many square feet of carpet does it take to cover the floor? I mean, you would never say negative 20 square feet, okay? Area itself, area is always positive. So in all the examples we've looked at, the function so far has been above the x-axis on the interval AB. And the definite integral just gives us the area between the graph of that y equal f of x, the x-axis, and the vertical lines A and B. Alright, but now, what if this is not the case? What if the graph dips below the x-axis on that interval a to b, or is entirely below the x-axis? Well, let's consider the definite integral from 0 to 3 of x minus 1 dx as an example. Okay? Now, there are two questions that we could ask. We could ask, what is the total shaded area? Do you see the total shaded area here? Notice I've graphed f of x equal x minus 1 on the interval 0 to 3. And I have shaded some area. What area have I shaded? I've shaded the region between the x-axis and the graph. So we could ask the question, if this is a region, this shaded region is a region on the floor, for example, how much carpet, how many square feet of carpet would we need to cover this? That's one question. In that case, would I not just find the area of this triangle? Remember, area is always positive. Find the area of this other triangle, add them together. So let's just answer that question. What's the area of this triangle? Area of a triangle is 1/2 base times height. So that's 1/2. The base here is 1. The height is 1. So the area of this first triangle is 1/2 square unit. And we could just see that that's 1/2 of one of these 1 by 1 squares, right? So that's correct. Now what's the area of this triangle? It's 1/2 base times height. So it's 1/2. The base is 2. The height's 2. Right? The height's 2. And the base is 2. So 1/2 of 2 is 1 times 2 is 2. 2 square units. So what is the total shaded area? It's 2.5 square units. That's the answer to question 1. But question 2 is a different question. What is the value of the definite integral from 0 to 3 of x minus 1 dx? And we know that by the definite integral, we mean the limit of a sum. Okay? Now, Let's draw in the ith rectangle. Let's draw in the ith rectangle over here. And let's draw in an ith rectangle. It's just a typical rectangle. And let's draw in an ith rectangle over here in the portion where the graph drops below the x-axis. Okay? Can you see that for this rectangle, f of x sub I star delta x is going to be positive? Because f of x sub I is positive. Delta x is always positive. But for this rectangle, f of x sub I star delta x is going to be negative. And the reason is f of x sub I star is a negative number. Oh, the area of this rectangle is positive, but area is always positive, but f of x sub I star delta x is really it's a negative. It's the negative of the area of the rectangle. So what's happening when I take the sum of areas of the n rectangles? What's happening when I take this sum? I'm getting some of those added to what? A bunch of negatives. What's going to happen is that this definite integral from 0 to 3, the value of it is the value of the limit of the sum of the areas of these rectangles. It's going to be the area above the x-axis minus the area below the x-axis, which we call net area. So if the graph falls below the x-axis on the interval a to b, the definite integral gives us net area. Now, what's the value of this definite integral going to be? Well, what's the area of this triangle? We figured that a minute ago to be what? 1/2 base times height, 1/2 2 times 2. So we got 1/2 of 4, which is 2. So what's going to be the value of this definite integral? It's going to be the area of this triangle because it's above the axis, and that was 2. But the area of this triangle is below the axis, and its area a minute ago we found was 1/2. So we have to subtract the 1/2. And we see that the value of the definite integral from 0 to 3 of x minus 1 dx is 1.5. That's the net area. That's the total. There's 1.5 more units of area above the x-axis than there is below. So a definite integral gives us net area. If the function is totally above the x-axis, net area and area are the same thing.